for our first chapter, again dealing with pure substances. Now we're dealing with the let's try again. What? Subcapital. Okay, try again. 1, 2, 3. Hey, welcome back. We're now in the second section of our first chapter, which deals with pure substances compounds. Now, a compound, as you probably know, and you should be somewhat familiar with this, is any substance in which you have 2 or more atoms that are bonded to form one substance. So, this is a step up from elements. You're combining elements to create a compound. And the part of the element that we are looking at, of course, are atoms, and we'll get into that much later as well. Examples. Carbon dioxide, CO2. Now, carbon dioxide is a gas, so we can't see it. There's no color to carbon dioxide. Now, some gases do have color. Fluorine, for example, is yellow. Pure fluorine is yellow. It's not the stuff you find in toothpaste. That's fluoride, and that's something completely altogether different. Table salt is sodium chloride, as you well know, but chlorine and sodium are both explosive by themselves. Now let's take a look at this on the periodic chart that we have been looking at. Sodium is over here. These are called alkali metals, and alkali metals are extremely reactive. They explode in contact with water. It's really kind of fun to watch. Chlorine is right over here. This column right here is called the halogens. The word halogen means salt maker. I believe the Greeks came up with that one. And chlorine is a yellow-green gas. It is nasty, awful gas. They used it in World War I. They called it mustard gas. It looks like mustard floating around there. You put the two together, a violent explosion occurs, and the result is table salt, which is harmless. Because the transformation from an element to a compound goes through all kinds of changes. I have here a compound. This is cobalt nitrate. Now, cobalt is right here, element number 27. Cobalt is a fairly harmless metal. Oops, I thought I had cobalt. It looks like cadmium. This is cadmium right here, which is like a very silvery metal. It kind of looks like zinc as well. But cobalt, when mixed with nitrogen and oxygen, which creates the nitrate, turns this really kind of a reddish, almost puce color, if you know what puce is. I'm ashamed to say that I do. They took my man card the first time I said that. I don't have it anymore, but I'm still a man. Anyway, so the transformation from an element to a compound results in different characteristics. And those characteristics are called properties, and we'll be getting to that again later on as well. But right now, all we need to do is to identify compounds. So the question comes into play here. Here's table sugar. Table sugar is a combination of carbon. Carbon is a black solid, charcoal. If you have charcoal at home, it's mainly carbon. It's about 85 to 95% carbon. Hydrogen and oxygen, which are colorless, but you put them all together and you get this white crystal. In here I have some pure magnesium. Now, magnesium is found in plants. And in the plants that they become green because of the presence of magnesium. But this is magnesium that they make sparklers out of. This stuff is very thin and light, the way they manufacture it. And of course, when you strike a match to it, it gets really hot and shoots off sparks. But plants, with the compounds that make it what we call chlorophyll, that allows the sunlight to hit these chlorophylls and converts carbon dioxide and water into a sugar and oxygen. Now, it's just a weird process because the properties of these things completely change. One more thing I'll show you before we get into this last part here. This is sodium hydroxide. Now most compounds don't turn pretty colors like this. These things are flakes. You can't really see. I'll pour it out right here. These flakes of white is pretty common for compounds that are developed here. Sugar is white, sodium chloride is white, a lot of things are white for whatever reason. But sometimes, like I said, like cobalt nitrate or other compounds, manganese nitrate, copper sulfate. You can't see it too well, but copper sulfate is just a flat out pretty blue color here and messy. So, how do we know? Do we just look at it and say, oh, I know that's a compound or it's an element? Well, again, it comes back to this. If the substance you're looking at has more than one of these things combined with another one of these things, it's a compound. It's that simple. So, example, is protactinium an element or compound? Well, let's go to the periodic chart, periodic table, and find out. Protactinium. What's the symbol for protactinium? I don't think it's even on the thing I gave you, so you have to dig real hard. But there it is, element number 91, just short of uranium. Protactinium. If it's there by itself, element. So the periodic chart helps you a lot with the subcategories of compound and elements. All right, let's do another one. Is nitrous oxide an element or a compound? Now, does everybody know what nitrous oxide is? Well, if you've ever been to a dentist, you might know nitrous oxide is the gas that they give you, so you don't really care if he's creating a lot of pain in your mouth. A lot of people seem to like nitrous oxide. Nitrous oxide. Well, there's oxygen, but that's not the name. It's not oxygen. There's nitrogen, but it's not nitrogen. It's nitrous. It's not oxygen. It's oxide, and they got them both together. Compound. So, there's some practice problems involved in this. And like I said, I'm sending you this sheet is available. These are the practice problems here. Go through those and see if you can figure out which are the compounds and which are the elements. They're all pure substances. You just need to figure out which is which.